So we've done generate a name for the buffer, bind or activate the buffer, and store data in the buffer. And the data that we're storing in the buffer, it actually comes out of here. So you've learned already about vectors, that you can use pushback on a vector, and we're pushing a bunch of values. So and we're pushing XYZ values. Okay, so the X value, in this case, the X value is changing each time. So it's going from minus 0.4 F to, to around 5.0, right? So from minus 4 to 5. And each time we're pushing that value as X, and we're pushing zeros for Y and Z. Okay, because remember, this is 3D rendering. Even though it doesn't look very 3D when it gets done. But anyway, we've pushed all those values into vertices, and that's what we're loading up. So we're passing all that information over to OpenGL so that OpenGL can render it. So basically, this was all just like setting up OpenGL to be ready for the information, and then passing the information. And we still haven't asked OpenGL to draw anything. So that comes in the rendering bit, and that's actually our render method. So that's a separate method. So all this setup stuff happens in init. That kind of makes sense, right? And then when we're ready to draw, that's when we're going to do the rendering. Okay, so in other words, if you look at main, what happens is, where is it? Yeah, we call this init first, and then the render bit gets called later on down here. Okay, so when we've at the point of rendering, now we're going to actually use the buffer that we set up to do the rendering. So here first thing is we clear the color buffer, and so we're clearing the color buffer. So because we have this GL clear, right, and it says clear the color buffer and clear the depth buffer bit. Clear the depth buffer. Okay, so GL color. Remember, we set that up already ahead of time, so that when we clear the color, it clears with these values, so it comes out gray. So the background's going to be gray, and the depth buffer. I'm not 100%, but I'm pretty sure that has to do with the the Z depth buffering. So we have this GL depth test. I think that has something to do with that. Okay. Where else? Okay, then we do this GL load identity. Again, not. This is something we're not going to get into in this lesson. It has to do with matrices and that are used for transformations and stuff like that. And really, this is just loading up the identity matrix, which just means we're not doing any kind of transforms here. We're not rotating or scaling or translating anything like that. Then the next thing here is glue look at, and what this does is basically it sets the camera, so when you're in 3D space, you have to think about where am I in space, and what am I looking at, basically, right? So well, actually, there's three things. You're looking at where am I in space. So where is the eye? And here's the X, Y, Z values for the eye, are these first three values, right? For your eye. And then the center X, center Y, center Z is basically what am I looking at. So that's the three coordinates, the X, Y, Z coordinates for the thing that you're looking at. And then this up X, up Y, up Z, basically is used to just tell you which way is up, because that's important too, right? When you're viewing something. Okay, so so that's what the glue look at does, and then yeah, we need to enable a vertex array here. So basically what we're doing is, remember we passed those vertices where this is kind of like set up stuff to make sure we're correctly accessing that vertex buffer object. So this vertex buffer, remember now, it contains everything from the m vertices from that vector. Is now, this is how OpenGL refers to everything that was in that vector, because we passed it that setup information. So we're activating this buffer that we loaded up earlier, and then there's this GL vertex pointer business. So what that does is it basically says, since we're saying GL vertex pointer, we're saying the array that I sent you is an array of vertices. It's an array of points in space or positions. Okay, it could have been a color pointer or something like that. Then we would have said GL color pointer. But we're saying GL vertex pointer, so it's a bunch of positions in space. There's a 3 here which says that each vertex has 3 elements, because there's an X, a Y, and a Z component to each item. Okay, so when we're looking at that, so when OpenGL, because OpenGL just basically has a whole bunch of numbers right next to each other. That's what it sees from the vector that we passed it, right? So you're telling OpenGL, chunk those 3 at a time, because because there's they come in 3s for the X, Y, Z components. Okay, and then GL float tells you that they're stored as floats. This 0 right here is called the stride, and that is just if there's any padding between vertices, like there could be, I don't know, there could be strings of us, there could be a character between each set of vertices or something like that, right? So in that case, you would, or something of a specific length that's between each vertex, then you would put that number. But here all we're storing is vertices. There's nothing in between them, so I put a 0. And then this 0 just says basically start at the first position in the array that you have. Okay, and you could actually pass it a pointer to some random spot in the array if you wanted to, but we're specifically requesting to start at the beginning of the array. Okay, and then so now to render, what we got to do is we're going to remember the picture showed points that were small and got bigger and bigger and bigger. We're starting out with a point size of 0.5, okay, and incrementing the point size, and then we're also in this for loop, we're looping through our vertices. Okay, so remember our vertices are X, Y, Z components, right? So there's 3 floats for each vertex. So we have to get the actual number, the number of actual vertices, the actual number of positions, we have to divide by 3. Okay, because they come in groups of X, Y, Z, X, Y, Z, X, Y, Z, like that. Okay. So yeah, so we're looping through I equals 0 up to the number of vertices, and then we increment I each time. And in here, what we do is we set the point size, right? because remember we said we're starting out with these small points and getting bigger and bigger. So this GL point size sets the point size in pixels, and then we have this GL draw arrays, and that is the basically that's used. It's used for rendering arrays. In this case, what we're doing is we're drawing points. Okay, so that's where the GL points comes from. The I says give me the point at the location that given by m vertices I. Okay. Oh wait, is that right? It's the ith. Yeah, this is not a good way to say it. It's actually going to be I times 3, isn't it? Because we said that it's stored in sets of 3. So we're going to draw the point, because this actually is going to be a group of 3 floats, right? So we're going to draw the point at the ith location, and the 1 says that we're just going to draw 1 point. Okay, and then we increment the point size. Alright, and then it says disable the client state when you're done with the array. Okay, so that's what we're doing here. We're saying disable client state, and we're passing it the vertex array because we're done with it. So in general, it's always good to, like, when you're done using something, release it so that it's not you're not taking up space with it anymore. Then there's this other stuff. Shutdown doesn't do anything. On resize does some more GL stuff that's kind of Windows stuff. What happens when you redo the window? We don't really care about that. So, but I just wanted to give you a quick run through of the GL stuff, just to give you a general idea, just so it's not like a complete mystery. But to actually do the actual assignment, a lot of this stuff you can ignore. So it's not important to understand all this stuff in detail. But I just wanted to give you a quick run through just to have a sense of what's going on, so it's not all like another language. So then in the next video I'll give you the assignment that goes with this project.